The lava flow trail and the porta potties.
We can just do part of it.
Yeah. Yeah, just a little bit. We don't need to do a ton. Hold on, Sarah. You hear that? Exactly. No, you can actually drive over it as long as it doesn't exceed 5,000 pounds. So I better get off it. Look at that lava go right through there. There's other cones in the distance. Sunset Crater Facts. Here, eruption date, sometime between 1040 and 1100 AD. Hey, it is November 12th, 2020. It's about 28 degrees Fahrenheit out, so minus 1 or 2 degrees Celsius, somewhere in there. We are at 35.36272 north by 111.51563 west. We are at Sunset Crater, I guess you call it here. You can see the mountain behind me. It's now preserved. You can see these lava flows behind me. What's really interesting about what is behind me is this thing here, and these flows around here are 11th century. That's when this stuff erupted. So we're talking mid 1050s to 1100, some of the signs say, somewhere in that area. So there were already people here when this lava erupted, and you might be thinking, oh, so what, Steve? Lava, big deal. Well, here's the thing. We are not on the northwest coast. We are not in Hawaii. We, as you can probably tell by the snow, we are not in Iceland or anywhere near a continental margin where you would expect to see stuff like this. We are in northern Arizona on US 89 north of Flagstaff. This is the youngest of them, but there's others around us, like a total of about 600, I think, of these little cinder cones, varying in age from about 200,000 years ago to about 2.5 million years ago, somewhere in there. So this stuff is young, and then you get the occasional really young guy like this. And the good thing about this stuff being so young, you know, even though I study old rocks, is that a lot of the primary structures in the lava are preserved. It hasn't been buried with other stuff, other lavas or other sediments, and hasn't been deformed. So you see a lot of primary structures, and a lot of the eruption is preserved. If we look over here And this will tell you what, but I'll just go through it with you. You see this crack here? This is awesome. How this formed basically is there was a land surface, all right, and you had lava, already hardened lava, and then you had magma, because technically it's underground just at this point, under this, and it pushed up a little bit, doming up the already hardened lava, forcing it to crack, and then that lava itself cooled. That's basically what this is saying here. You have solid crust, would have been your hard lava. You had molten under it, and this can be caused by numerous things. This could have been a tube of lava under a solid surface, or it could have just been a blob of it from deep underneath. But you can see and then it cools, and it causes it to crack as it thickens, and then any lava, magma, I guess at this point it doesn't really matter because we're talking tens of meters here, not even several meters. We're not talking about hundreds of meters underground, a few dozen feet. So that's how this structure formed, and you see a lot of that kind of stuff here. And if you look around, even the lavas, you'll see primary flows. You'll see flow banding in it, and you see it's very porous where it had gas in it, and the gas escaped as this stuff solidified. And if you look back there, you'll see older cones as well. And this whole area is riddled with it. We will be continuing north, and we will soon be leaving this area and getting into sedimentary rocks, Mesozoic rocks, Paleozoic rocks, and stuff like that.